हेलो एवरीवन, कैसे हैं आप सब लोग। वेलकम टू एड्यूशॉर्स 50 डे 50 टॉपिक्स कोर्स फॉर यूजीसी नेट जेआरएफ इकोनॉमिक्स एग्जाम. Today is mathematics day and today I will be covering a very interesting and easy topic comparatively, which is LPP, that is linear programming problem. Okay, so first of all we have to learn why do we have the term linear over here. So, what is the meaning of linear? Linear means the powers of the variables. The powers of the variables is equal to 1. We cannot have any other power. Okay. So, basically, what will be the structure of the linear programming problem? You will have to maximize or minimize an expression of the type ax plus by. I call it as z. Okay, where x, y are variables. And since you are economic students, mostly x and y are number of units of some quantity produced. So therefore, x and y will always be greater than or equal to 0. They cannot be negative. So basically, this is known as non-negativity constraint. What do you mean by constraint? Constraint is that I am putting some limit on the problem. The limit is that x cannot be negative, y cannot be negative. So therefore, these are known as non-negativity constraints. It will always hold. Okay. So we will have to maximize and minimize z is equal to ax plus by subject to certain conditions. So what will the conditions be? The conditions will be inequalities. Okay. So what are the inequalities? They will look like this: cx plus dy less than or equal to e, mx plus ny greater than or equal to f, something like this, etc. And we already have these non-negativity constraints. Okay. So this is known as objective function. The function which we are maximizing or minimizing is known as an objective function. The conditions which are there under which we have to maximize or minimize the function, they are known as constraints. Okay. Now these terms are very important because sometimes they will directly ask you the meaning of constraints, objective function in a linear programming problem in an MCQ. So you should be well aware of these terminologies. Okay. So how do we maximize or minimize a problem? So I will be discussing the most common method, which is known as corner point method. And this is very, this is the most optimal method from UGC's point of view because the questions are not difficult. So corner point method is the best way to deal with a UGC net problem on linear programming. Okay. So let me start with the problem. So I'll start with a question. So let me write the question for you. The question is, we have to minimize z equals to 200x plus 500y subject to x plus 2y greater than or equal to 10, 3x plus 4y less than or equal to 24, and x greater than or equal to 0, y greater than or equal to 0. So you are being given an objective function and the constraints are already there. Okay. So this is your objective function and these are your constraints. Okay. So what is the process to find maxima or minima? So here we have to find out minima. So what we will do, we have to look at these inequality. So inequality number 1 is x plus 2y greater than or equal to 10. So what we do, we will write the equation first and plot this. This is going to be a line. So let me plot this. So I take two values, x, y. So put x equals to 0, y equals to 5. Put y equals to 0, x equals to 10. Safest value. Then second inequality is 3x plus 4y less than or equal to 24. I write the equation 3x plus 4y equals to 24. So what will we do? Again, x, y, input two values. We need only two values to draw a straight line. So put x equals to 0, y will be 6. Put y will equals to 0, x will be 8. So now what is the next step? The next step, we will draw these lines. So let's draw these lines. Okay. So this is x-axis. This is a y-axis. So let me use different colors for these lines so that it is easily acceptable and visible to you people. Okay. So x0, y5. So we have 5 over here and x10, y0. Suppose we have 10 over here. I'm making a rough figure. So my line is going to be like this. And then we have this one, 3x plus 4y equals to 24, x0, y6. So somewhere over here, and x8, y0. So somewhere over here. So I will have a line like this. Okay. Now, what we have to do next is we have to shade the inequality. So let us look at the first one represented by the yellow line. So we want x plus 2y greater than or equal to 10. So how do I know that whether I am above the yellow line or I am below the yellow line? Okay. So choose a point of your choice, below the line or above the line. So here 0, 0 is below the line. So let us put 0, 0 in the inequality. 0 plus 2 times 0 greater than or equal to 10. 0 greater than or equal to 10. It is false. Therefore, I will be plotting the area above the yellow line. Okay. So 0, 0 region is not included for this yellow line. Okay. Similarly, if I look at the green one, okay, the green one is 3x plus 4y less than or equal to 24. So again, below the green, I have 0, 0, put 0, 0, 3 times 0 plus 4 times 0 less than or equal to 24, 0 less than or equal to 24. This is true. So I will go below the green line, but above the yellow line. Okay. So that means this is my area, common area that I am looking at. Okay. If you look at it carefully, the shaded region is my region where I'm looking at. Now, the region in the two-dimensional plane that is satisfied by all the constraints. You can see that x is greater than or equal to 0, y is greater than or equal to 0. Therefore, I am not going towards the negative sides. I am only looking in the first quadrant. So this shaded area, this common shaded area, which is satisfied by all the constraints, this shaded area is known as basic feasible region. Another definition which is very important from MCQ point of view. So this is the feasible region. Okay. So what is the next step? Why this is called a corner point method? So in the next step, I will have to calculate these corners of this shaded region. Okay. So you can see this corner, name it as A, was 0, 5. This corner B was 0, 6. And I have to find out the corner C. Now, how do I find the corner C? Corner C is the point of intersections of these two lines. X plus 2y equals to 10 and 3x plus 4y equals to 24. So let's multiply the first equation by 3 and subtract. So 3x minus 3x 0, 6y minus 4y 2y, 30 minus 24 8. So y is coming out to be 4. So x will come out to be 2. So this is 2, 4. Let's see whether we are correct or not. X equals to 2 plus 2 times 4 is 10. And then 3 times 2 is 6. And 4 times 4 is 16. But 6 plus 16 is not 24. So we will have to check where we went wrong. Okay, so 30 minus 24 is 6. So y is coming out to be 3. If y is 3, x will be 4. So let's put now 4 plus 2 into 3 will be 10. And here 3 into 4 plus 4 into 3 will be 24. Now we are correct. So this particular point is going to be 4, 3. Okay. So now we are coming to the end of solving this problem. So what we will do now, we are going to create a table. Okay. So we are going to create a table. Okay. So here we will write corner points. So the first corner point is A, 0, 5. The second corner point is B, 0, 6. The third corner point is C, 4, 3. Then we write the value of Z over here, which is 200x plus 500y. So let's calculate 200 into 0, 0 plus 500 into 5, 2500, 0, 6, 3000 and 4, 3. So it is going to be 200 into 4 plus 500 into 3. So which is 800 plus 1500, which is 2300. So 2300. So you have to look at the values only at the corner point. The solution of a linear programming problem will only be at the corner point. That is a very important theorem. So you can see that the minimum value is 2300. So what is the minimum value? What is the minimum value? The minimum value is 2300 at 4, 3. That is at x equals to 4, y equals to 3, we are having the minimum value. Similarly, if in the same problem you were asked to calculate the maximum value, the maximum value was 3000 at 0, 6. Okay. So that is how you calculate maxima or minima of a linear programming problem. So we go to the next problem and let's maximize this time. So let's write the next problem of maxima and minima. Okay. Maximize z equals to 5x plus 3y subject to x plus 2y less than or equal to 8, 3x plus 2y less than or equal to 12, x greater than or equal to 0, y greater than or equal to 0. So let's start now one by one. So let's go to the first one. X plus 2y equals to 8. Make a table of values to plot x, y, x0, y4, y0, x8. The second one, let's do it by another color, using another color. So 3x plus 2y equals to 12. So this is x, this is y, x is 0, y is 6, y is 0, x is 4. So now let's plot. This is x axis, this is y axis, and then we will be using colors now. So let's use the pink color for the pink one. So x0, y4, so we have 0, 4. x8, y0, we have 8, 0. This is my first line. Then we have the yellow one. So x0, y6 is going to be here, 0, 6. x4, y0 is going to be here. Okay. So now let's try to plot the common area. So let's see. Now we have x plus 2y. In both we have less than or equal to inequality. Let us look at this particular point 0, 0. So try. In both inequalities, if I put 0 in the first one, 0 plus 0 less than or equal to 8, true. In the second one, 0 plus 2 times 0 less than or equal to 12, true. So that means the origin will be included in the basic feasible region. So I have to be below both these lines. So this area, the one which I'm shading, is the basic feasible region. So let's call this corner point A, B, C, and D. And I have to find out D now. Now D is the point of intersection of x plus 2y equals to 8 and 3x plus 2y equals to 12. Let us subtract. So you'll get minus 2x is equal to minus 4. So x is equal to 2. You put x equals to 2 here. 2 plus 2y is equal to 8. 2y equals to 6. Y equals to 3. So D is 2, 3. Please verify. X equals to 2, y equals to 3, 8. True. And then x equals to 3. That means x equals to 2. That means 6. And 2 times 3, 6 is equal to 12. True. So our corner points are correct now. Now let's make the table. So corner point 0, 0, corner point 4, 0, corner point 0, 4, and corner point D 2, 3. And my Z is 5x plus 3y. So this is going to be 0. This is going to be 20. This is going to be 12. And this is going to be 5 times 2 plus 3 times 3, which is going to be 16. So the maximum value occurs at 4, 0. You can see that. So that is how you tackle the maxima and minima using the corner point method. This is the basic of linear programming problem. You should know what are non-negativity constraint. You should know what is basic feasible region. You should know what you mean by an objective function for MCQs. Okay, the definition has to be very, very clear. Now, so what are the notes? The first note is that maxima or minima of a LPP occurs only at corner points. So therefore, we are calculating the corner points. Second, if max oblique min occurs at 2 points. Now, it is also possible that we have a maxima minima at 2 points. At 2 corners, we are getting the same value. So for example, let the points be A, B. Then maxima minima will occur on the entire line segment AB. That means if I have a point A and if I have a point B, both are corner points, there is a maxima at A, there is a maxima at B, then the maxima will occur at all the points joining the line segment A and B. So that means we will have infinite solutions. Okay. So a linear programming problem will never ever have a possibility of 2 solutions or 3 solutions. So what are the possibilities? First is no solution. There are cases when there are no solutions. Second possibility, unique solution. And what is the third possibility? Infinite solutions. Okay. So there are possibilities when there are infinite solutions. So sometimes they can modify the MCQ in such a way that they will say an LPP has 1 solution, 2 solution, 3 solution, or infinite solutions. Which of the following are correct? So you can see that option number A and D will be correct. We cannot have 2 solutions and 3 solutions. So we either have 0 solutions, or we have unique solution, or we have infinite solution. So this is all about linear programming problem. See you next time. All the best. Please keep on visiting our channel for more interesting and relevant stuff for preparation of UGC NET and JRF. Thank you.